So area and circumference. The biggest thing is just remembering, it's been a hot minute since you've done area and circumference necessarily of a circle, other than in volume. But I feel like for a lot of people, it still is kind of far away. So area of a circle is pi r squared. Whoa, why is that doing that? And that's something you have to remember. So when we have the center and we have the area, we're missing our radius. So if the area is 1 pi, and I just put the 1 in front of it because remember it's imaginary, is equal to pi r squared, I need to get radius squared by itself. So what's attached to the radius squared that needs to go away? Pi. So we're going to divide both sides by pi because that makes these go away. These are going to magically go away as well. So 1 equals radius squared. All you need is radius or radius squared and your center to write the equation. So that's just going to be x minus, because this is our h and our k, 12 squared plus y minus 16 squared equals radius squared, which is 1. I feel like that was almost too easy. So I'm going to do this one really quick. Area is pi r squared. So the area is 25 pi equals pi r squared. Again, same thing. You're trying to get radius squared by itself or radius by itself, depending on the question. But if we're writing the equation of the circle, all you need is radius squared. So it's 25 equals radius squared, which means if we want to know what the radius was, we take the square root of both sides, and the radius would be 5. But again, writing the equation of the circle, it's x minus h, y minus k, both of those squared. So x minus, and we'll just leave it 9 over 2 for right now because that's a whole nother conversation. Y minus plus 1, because minus minus squared equals, and that's where our 25 would go. And now you've written the equation of the circle. So even though it may not feel like it initially, it would be a gift of a question if you remember the outline of the circle's equation and you remember area of a circle. Not super complicated relative to a lot of the math you guys do in Math 3. So circumference is 2 pi r. Some teachers teach it as pi diameter. I don't hate it. The logic is there, but then you have to think through. And if that's the way you have it memorized, I'm not trying to unmemorize. But if you don't have one memorized at all, I go with 2 pi r because what you need is radius. So the circumference is 18 pi. So C is 18 pi equals 2 pi r. We need the r by itself. You can divide by 2 and then keep going, and then by pi, or they're both multiplication, so we could divide by them both at the same time. Then 18 divided by 2 is going to give me 9. So our radius is 9. Slightly different than before because now we need to square that because r squared is what we need for our equation, and 9 times 9 is 81. We have our center, so that's x minus 3 because it's a positive 3 squared plus y, so minus 7, so that's going to become a positive 7 squared equals 81. So again, the big call out, and I feel like I've been teaching factoring this morning, so this feels way too easy. Remember in this equation, and then remembering that the circle equation is x minus h squared plus y minus k squared equals radius squared. Call out being radius squared, and h and k is your center. So again, just as review. And then maybe I would say remind yourself these are minuses. So if you plug in a negative, the equation shows up as a positive. All right, identifying the center and the radius of each. I pulled 5 because I feel like it's pretty self-explanatory that we would move the x over and not everything else to the other side. Number 6, we won't work on both, but if these guys are both negative, you would be better off to switch the symbol of everything and switch their sides. Like you're just going to switch it across the equal marks to make everything on this side opposite, because then x squared and y squared would be positive. If they become negative, it does change the process, and you don't need to jump in that deep in. It's not necessary. So we're going to move this guy this way. So I end up with a positive x squared. Then I'm going to go ahead and put it in order. Negative 26x. That's our x's together, so we get a blank. Then I have y squared and nothing else. So we can put a blank for giggles. And then we're going to move that constant to the right side by itself. So it's going to become a negative 65. And remember, if you have one blank, you need to have two blanks. I'm sorry. If you have blanks on the left side, however many, you need to have them on the right side. The fun part, this blank is just optional because you don't have a B value. So it is not going to really, nothing's going to go there. It would be a 0. But if a habit is a habit, keep it. Then we're going to take our B value, divide by 2. Then we're going to square that. And this is the part where I said you guys always, it takes a little while for students to understand why I write that negative 13 part out. If we square that negative 13, we end up with 169. So that's going to go 169, 169. So again, for the orange, there is no B value. So it would be 0 divided by 2, which is 0. If we square it, that's 0. So this is 0, 0. Or again, skip it if there's no B value. You don't have to write any of the stuff that I wrote in orange if you don't want to. We're going to now factor this first guy. I'm sorry, you do need to write the y squared, not the orange blanks or any of this orange bottom part. We factor it, so it's going to be x minus 13 squared, because a negative 13 plus a negative 13 gives us that negative 26. A negative 13 times a negative 13 gives us that positive 169. It'd be plus, in this case, y squared just comes down, equals, this was, I've already said this in one of our previous live classes, this is where I saw lots of misunderstanding on the ed puzzles, but you're just going to total this outside. So if I owe you 165 and I pay you 169, that's a positive 4. You've now converted the equation. Your center is going to be positive 13, because remember it's x minus h, and 0 for our y value because there's nothing there. And then our radius is the square root of 4. So that's going to be 2. So square root of whatever, because this is radius squared. And to undo squaring something, you're going to find the square root. And that's where the 2 comes from. All right, because of our previous conversation, we're going to finish up on that guy and work our way down our sheet. So number 7. If the angle's vertex is on the center of the circle, it is a central angle. Central angles are equal to the intercepted arc. And that just means the arc in which it makes. So like this angle, this is also the measure of that anterior angle. This example, number 7, you would see this 76, hopefully, and then this 10x plus 6 as vertical angles. And vertical angles are congruent. So we would set it up. 76 equals 10x plus 6 and solve. We only have 15 minutes, so I'm not going to use our time to solve equations. I'm just going to set everything up so that way you can see the way it's set up. If we need to go back, just holler and we'll backtrack. Number 8, so since it's solved for x, where we need to focus is this arc. That means that 95 at this point is just too much information. It's fluff. Because x plus 39, this arc is the same as this angle, which they tell us is 30. Because it is a central angle again, because the vertex is on the center point. So it's going to be x plus 39 is equal to 30, solve for x. Most of the central angle problems that are laid out like this, the students have the most issues because they give you too much information. And we just sort of panic because it's way too much. Okay? All right. Number 9. Oddly enough, you need all this information plus some. So again, paying attention, this is where we want to be. It's what we need to answer. So what is 23x equal to, or what is x equal to? Ideally, it'd be really cool if we had this angle, or if we had this entire angle on this side, because that would be our vertical angle. We only have part of it. We do have the arc at 65 degrees, which means this angle is 65 degrees, which is helpful because this angle is also 65 degrees. And we want to work on trying to get this guy. So again, we're shooting for this guy. This is a semicircle, which is equal to 180 degrees. I have 66 and I have 65. So the unknown for that 180 is just within that little pizza slice, which would then help me if I had that, because then I would have my vertical angles measure. So what we're going to do is take the 180, subtract 66, and subtract 65, or add 66 and 65 together, and then subtract it from 180, and you get 49. Which means this little angle is 49 degrees. Oh, I just wrote a 6. I made that up. 49 degrees. So then this two angles is 49 plus 66, which is 115, which means this angle is 115. Working our way out, that means it's equal. So it's going to be 23x equals 115. And then you're just going to divide to get your x by itself, which would be 5. So it's the setup, I think, more than the actual difficulty of the math. So it's just a matter of slowing down, using highlighters, sketching on your paper, trying to use different notations, and not jumping off the deep end, whether it be panicking or just grabbing numbers and slamming them together. So 55, we know this is 55. We know this is 70. We know this is x plus 63. But we are looking at this arc is what we need. Hopefully, we'll start to train ourselves to see that this is a semicircle, which is just half a circle. A full circle is 360, so that means it's going to be equal to 180. I used 55 and I used 70, so I'm going to add those together, and that's 125. So this much is 125, and then I have this left over. So I could subtract that from 180, or the mathy way that most of the time you're going to see this written, it's going to be this arc plus, and it was probably 70 plus 55 equals 180. And like we just figured out, you may also see it written like this. And again, you would just continue to clean up and combine like terms. And so you're down to this. Or if you went ahead and took the 125 from 180, you could set it up as x plus 63 is equal to 55. Both of those are correct. It's just a slightly different way. And I'm only calling that out. Not a big deal since we're not in a classroom, but you know you've been in a classroom where you look at your neighbor's paper trying to compare them and they're different. This is one of those situations you could get there slightly differently. Circles and quadrilaterals and all that good fun stuff, you can get there a little different. There's different paths to the right answer. So your work doesn't have to match mine or anyone else's as long as the answers are the same. All right. I feel like I'm going really fast. If you need me to slow down, give me a mayday, mayday. So those are central angles. These are inscribed angles. My favorite of these is where they combine the two, and they can put two in the same circle. As you can see, there's lots of stuff going on here. But inscribed is 1/2 the measure of the intercepted arc. So you are going to half it on the way in. Okay? Half it on the way in. So I see an X here, this angle, which intercepts this arc. Like its two legs touch that arc. The arc is 114. The angle is 9 plus 4x. So had it been central, we could set them equal. But the angle is half of the arc. So if I take the arc and divide it by 2, I can now solve this. So 114 divided by 2 is going to be 57. So you divide going in. Divide going in. Or if you want to work your way out, you can double going out. So again, that chance where my work might not match yours or your work might not match mine, I feel like halving 114 because I like smaller numbers is better, easier in my brain. But I could also set this up as doubling this side and set it equal to 114 and solve it that way. Setup is, both of those is correct. Again, the answer should be the same. I just like when the numbers get smaller, and this one would turn into a 57. But you always have a calculator, so small numbers aren't necessarily, lifesavers. Whichever way you see first. So number 12 is exactly the same, but different numbers. So this angle intercepts this arc. So I can double x plus 56, or I could half 112 and then set them equal. So 2 times x plus 56 is equal to 112, or x plus 56 is equal to half of 112, or 112 divided by 2. Maybe you're seeing where, like, if I wanted to simplify this, I would divide by 2, and that's how I get here, or vice versa, get 2 out of the basement and multiply. I don't know if the pattern is very noticeable, but again, either way is correct. You're just going to work through and solve at that point. Number 13. So we have arcs all the way around, and all they want to know is what is x. So when you see information all the way around a circle, a semicircle is 180. So a full circle, again as a review, is equal to 360. Ultimately, I can add all these together and set them equal to 360. There's not a way to make that any smaller or better because none of those lines cross through the center. So you can't get rid of any number. So the mathematically correct way, I've had students argue that they take 360, subtract this, and then set it up with just these two. That's fine. You're doing the long algebraic way. You're just doing it in a different order of operations, but it is still the same. So the super math teachery, make sure you get it all, would be this. I kind of like this way better because then I can just combine like terms and then move them around myself. But obviously, you do you. But all three of them are equal. The sum of them is equal to 360. Like I said, I'm going to keep going. We'll come back to solve if we need to solve. Number 14 is another inscribed angle. So this working its way out, because it looks like we got a lot of arc stuff going on here, means double it to go out. So 2 times x plus 85 would be the length of the arc. And again, this is just the way your brain works, because maybe it's easier for you to work your way in. Except we're missing a lot. Nope, this is the only way we can do it. Making sure I'm not over. Just kidding. That's all you got. Because otherwise you're missing the other leg to be able to work in the 61 or 129. So 2 times x plus 85, which we can go ahead and call 2x plus 170. That's the first one. Plus 61 plus 129 equals 360, because again, it's the entire circle. There's really not a way that I can tell you to make these any easier besides you just have to do them, and you have to slow down. So if you get behind and you're rushing through, that's what makes these hard, because unfortunately you just have to be fully committed to the problems to get them done. And then maybe fiddle around some. My biggest thing is the highlighters and the colored pens, because otherwise I feel like they're very, very offensive as far as just the layout on a piece of paper. I did skip angles inside the circle with tangents and all the lines and went straight. Grabbed this guy for just our segments because of the call out. Maybe I will try to work those in sooner than later. If you have issues with those, just holler. All right, so we have I'm going to do these out of order. I think 3 and 4 are the easiest, personally. The hardest thing I've seen people do is you don't identify which line is which, and you just grab numbers. So again, I feel like that's a rush issue. I can't tell you enough. The easy stuff in Math 3, if you slow down, should stay easy. When they are 2 chords in there, you're just going to take 4, multiply it by 2x, that line, and then we're going to take the 2 portions here, 5, and multiply it times x plus 3, then solve for x. So again, we're getting real close to time. I'm not going to solve it. Multiply, solve for x. We'll go back again. If you need help with solving, just holler. Number 1, So this is tangent, and this is a secant. So secants are my favorite. Again, you got to look at, there's a couple of things. So this is inside the circle, and then there's a segment that's outside the circle when I'm looking at this pink line. Outside goes outside the parentheses. The sum of the entire line goes inside the parentheses. So that's going to be -2 plus x plus 16. Then I have a tangent line, which only has an outside. So we're going to do x plus 4 times itself, squared. Which again, just to make sure we remember, that means it's x plus 4 written twice multiplied by itself. You would need to FOIL, like the blue side, clean up the left side here, and you end up with that -2 plus x times x plus 14. And you would FOIL or box method both sides and get it down to where it needs to be. You may end up with a quadratic where you have to factor. Again, if you are using Desmos, if you can get this far and this far, if you put this in line 1 and this in line 2 and then go find the intersection, you should have your answer. The setup part, I can't get you around. Like, you just have to do the setup part. So again, looking at the second one, this is inside the circle. So for our pink line, oh, I did all quadratic ones for this one. Woo! Was coming in hard on this one. So on the outside is 3x plus 3. That is going to be times the sum of this whole line, which is 3x plus 3 plus 48. So that's the first setup. Again, you want to clean this up. So 3x plus 3 times 3x plus 51. If you get that far, plug it in your first line of Desmos. If you don't want to get into the solving part, we have this side, which is x plus 5. 5x plus 5 squared. Again, remains 5x plus 5 times 5x plus 5. You can type it into Desmos either way, the top way or this bottom way, in your second line, and then again go look for their intersection if you want to get out of all the multiplications and then the factoring and then set equal to 0. Oh, one more. This is the same thing as the last one, except we don't have a tangent. We have 2 lines. This line, again, remembering this is inside the circle, which goes inside the parentheses. For the blue line, 7's on the outside. The inside is going to be 7 plus 2x plus 3. The order in which you write those two, it doesn't matter. It's the whole line. You're adding together everything that's the whole line. And then your second one, outside, goes outside the parentheses. And then the sum of the whole line goes on the inside, which is 6 plus 3x plus 3. And again, you could actually not even have to clean it up. You could probably type it in just like that in L1, like your first line, your second line. Look for your intersection, or combine like terms, distribute, and solve for x. This is going to stay linear, so it should be fairly easy. As long as there's not an x on the outside, they should be linear all the way through. Really quick, outside times the sum, which is x minus 5 plus x minus 3. Hot mess. If you wanted to clean it up, because they're all inside the same parentheses, you're just combining like terms. That's going to be 2x, 5, 6, 7, minus 8. So that's one side. Our opposite side is 4 on the outside. And then on the inside is 4 plus 2. Now, I had this conversation yesterday. Obviously, you know the sum of this whole line is 6. The only reason I write it out continuously as 4 plus 2 first is because that habit, you want it to stick. Because if you get really used to just turning that into a 6, and then you back up and go back to like a number 5, or like a number 1 or a number 2 on this page, you will 100% shut down and have nothing. You'll forget what you just did to get to that 6 because it looks ugly. So I'm just a habit. I like to form a habit that's going to work every time, whether it is super easy or super complicated. All right, guys, that was a lot.